Hello students, welcome back to the classroom point. In our previous classes, we have discussed the valence shell electron pair repulsion theory along with the how to identify the hybridization and what is the synopsis of the hybridization by taking the few examples. So in our today's class, we shall discuss some examples and how to identify the hybridization of the central atom in the given either molecule or cation or anion. So you might have seen many shortcuts to identify the hybridization, but in those shortcuts may be helpful in identifying the hybridization for only few examples. So in our today's class, we shall discuss the better shortcut that is helpful identifying the hybridization for the most of the molecules. So let's begin the class now. The first point here is find the total number of valence electrons of the given molecule or ion. So how to calculate the total number of valence electrons of all the atoms? So here we can see that total number of valence electrons is equals to valence electrons of all the atoms minus C plus A. So here V stands for the sum of the valence electrons of all the atoms, whereas C means charge on the cation. Charge on cation means in case of the positive charged ions, so the magnitude of the positive charge has to be subtracted from the total number of valence electrons. A stands for the charge on anion. Charge on anion means in case of negative charged ions, anions, the negative charge has to be added to the total number of valence electrons. So that in case of the cations, positive charge has to be subtracted, but in case of the anions, negative charge has to be added to the total number of valence electrons. So now the second one is, after finding the total number of valence electrons, so here total number of valence electrons may be less than or equals to 8, or else from the more than 8 in the sense 9 to 56. If the total number of valence electrons you are calculating in this step is less than or equals to 8, then directly hybridization is equals to whatever the value here you are getting the total number of valence electrons to be divided by the 2. So that you will get some answer that is called the quotient, plus if any remainder is there, remainder also you take. So sum of the quotient plus remainder is nothing but the hybridization. That means if the sum of the quotient plus remainder is equals to 2, that means 2 hybrid orbitals are present. So that they are S and P. So that hybridization is SP. If the value is 3 hybrid orbitals are present, SP2. If the value is 4 hybrid orbitals, 1 S orbital, remaining 3 are the P orbitals. So that SP3 hybridization. In case of 5, it is SP3D hybridization. In case of 6, it is SP3D2 hybridization. In case of 7, it is SP3D3 hybridization. But if the total number of valence electrons is more than 8 and up to 56, then hybridization is equals to here the total number of valence electrons to be divided by the 8. Less than 8 means use the 2, more than 8 means divide the total number of valence electrons with 8, so that you will get the some quotient answer along with the some remainder. But this remainder in this particular step has to be divided by again 2. So you will get the second answer quotient number 2, plus if any remainder is there, that should be the remainder 2. Now hybridization in this case is equals to all quotients Q1 plus Q2 plus, and the last remainder R2. So this is the hybridization. Now, while dividing the first remainder with 2, we must be ensure that if remainder is equals to 1, then don't divide with 2. Directly you take this 1 plus a quotient, that gives the hybridization. If the remainder is 2 or more than 2, then divide with the 2. So you will get the quotient plus remainder. Then sum of these two quotients plus remainder gives the hybridization. So this trick looks a little bit lengthy, but if you practice, it will be easy for you to understand the hybridization concept. So let us see these examples here, how to apply the trick whatever we discussed earlier. Here, sum of the valence electrons of the nitrogen and hydrogen. Nitrogen valence electrons are 5. 3 hydrogens are there. 3 into valence electron is equals to 1. Total number of valence electrons are 8. So this has to be divided with the 2. So the value is 4. That means 4 hybrid orbitals are there. So sp3 hybridization. And in this case of ammonium ion, nitrogen valence electrons are 5. Hydrogens 4 are there. 4 into 1. And one positive charge is there. Positive charge has to be subtracted from the total number of valence electrons. So this is 4 plus 5. 9 minus 1 equals to again 8. So that 8 by 2 equals to 4. Hybridization is sp3. In case of H2O molecule, oxygen valence electrons are 6. Hydrogens are 2 hydrogens are there. 2 into 1. So 2 plus 6 is equals to 8. 8 by 2 equals to 4. Hybridization is sp3. In case of H3O plus, oxygen valency electrons equals to 6. There are 3 hydrogens, 3 into 1, and 1 positive charge. Positive charge has to be subtracted. So 6 plus 3, 9. 9 minus 1 equals to again 8. 8 by 2 equals to 4. So hybridization is sp3. In case of BF4 minus, boron valence electrons 3 and fluorines are 4 are there. Each fluorine valence electrons are 7 and negative charge there means we have to add. So that here 3 plus this is 28 plus 1. So the value is equals to 32. 32 means more than 8. So that we have to divide it with the 8. So that we are getting directly quotient, no remainder is present. So that here 4 hybrid orbitals, again sp3 hybridization. Next, in the case of sulfuric acid, see here 2 hydrogens are there, 2 into 1 valence electrons plus sulfur only 1, that is 6 valence electrons plus 4 oxygens are there, 4 into 6. So let us try to calculate total number of valence electrons. Here 2, here 6. This is 24. So 24 plus 6, 30 plus 2, 32. So more than 8, that's why divide with the 8, so that you will get the 4 hybridization of the sulfur is equals to sp3. In the H2SO3 molecule, 2 hydrogens are there, 2 into 1 valence electrons, 1 sulfur, 6 valence electrons, 3 oxygens, 3 into 6. So total number of valence electrons here equals to 2 plus 6 plus 18. So 18 plus 2, 20 and 6 is equals to 26 divided by the 8. So it goes 3 times, 8 3s are 24 plus this is the quotient. Remainder how much is present? 2 is present. This is the remainder. So remainder has to be divided with 2. So remainder here is 2 by 2 is equals to 1 plus nothing is present. So this is the quotient 2. Then hybridization is equals to this quotient 3 plus this quotient 1. Total value equals to 4. So that hybridization is equals to 3. See here remainder is 2 or more than 2. That's why this remainder has to be divided with again 2, and now we are getting the answer. If any remainder comes here, that remainder quotient plus quotient gives the number of hybrid orbitals. Next, in the case of H3PO4, 3 hydrogens are there, 3 into 1 plus 1 phosphorus, valence electrons are 5, 4 oxygens are present, 4 into each oxygen valence electrons are equals to 6. So this is equals to 24, 24 plus 5 is equals to 29, 29 plus 3 is equals to 32. 32 divided by 8. 4. Hybridization is equals to sp3. In case of HNO3, 1 hydrogen is present. So 1 into 1 plus nitrogen valency electrons equals to 5 and 3 oxygen atoms are there. So 3 into each oxygen equals to 6. So total number of valence electrons 18 plus 6 is equals to 24 by 8. It is equals to 3. 3 hybrid orbitals are possible, that is sp2 hybridization. See that hybridization is always calculated only for the central atom. So here nitrogen central atom, here phosphorus, there sulfur, like this here nitrogen, nitrogen, oxygen, oxygen, boron, sulfur, like this. Only for central atoms we are calculating the hybridization. Now let us see the SO2 molecule. Sulfur valence electrons are 6, 2 oxygens, 2 into 6. So total number of valence electrons are 18. So 18 by 8. 8 to the 16 plus remainder 2 is present. So here we got the quotient and remainder. So this remainder has to be divided by 2 again. So that 2 by 2 is equals to, you are getting the 1, that is quotient 2. So now your answer is quotient 1 plus quotient 2. But here remainder is not there. So that hybridization is equals to Q1 is 2, Q2 is 1. So that 2 plus 1 is equals to 3. So that sp2 hybridization. And in the case of the SO3, 6 is the number of valence electrons of sulfur and oxygens, 3 oxygens are there, 3 into 6. Total number of valence electrons 24 divided by 8. So 3, then hybridization is equals to sp2 hybridization. In case of CO molecule, carbon valence electrons are 4, oxygen valence electrons are 6, so that it is 10 by, so more than 8 means 10, so 10 by 8. So 8 ones are, next remaining 2 is the remainder, this is the quotient 1, this is the remainder 1, then remainder has to be divided by again the 2, so that we get the next quotient, that is quotient 2, so that quotient 1 plus quotient 2, 1 plus 1 is equals to 2. So hybridization of the carbon in this CO molecule is equals to sp hybridization. So like this we can calculate. Let us see few more examples. These are the basic examples. Now let us try to see the example that are asking in the usually in the entrance examinations. In these examples here, total number of valence electrons, carbon valence electrons are 4 and 3 oxygens are there, 3 into 6 plus negative charge 2 valence electrons. So here this is 18 plus 2 20 and 4, 24 valence electrons are there total to be divided by the 8. So that we are getting the 3 hybridization of the carbon here is sp2. And next, carbon hybridization in the cyanodium, carbon valence electrons are 4, nitrogen valence electrons are 5, extra 1 negative charge is there, so that has to be added. Total number of valence electrons are 10, so 10 divided by 8. So 8 ones, 8 plus this is the quotient, remainder is 2. So that remainder has to be divided by the 2, so that we get the next quotient, that is 1, quotient 2. So quotient 1 plus quotient 2, answer is 1 plus 1 is equals to 2. That means hybridization of the carbon in cyanodium is sp hybridization. In N2O molecule, 2 nitrogens are there, each nitrogen valence electrons are 5 plus 1 oxygen valence electrons are 6. So 10 plus 6 equals to 16 by 8. So that it is equals to 2. Hybridization of nitrogen in N2O molecule is sp hybridization. If you take the PCl5 molecule, phosphorus valence electrons are 5 plus 5 chlorines are there. Each chlorine is having the 7 valence electrons. So this is 35 plus 5 is equals to 40. This has to be divided by the 8. So we are getting the answer 5. That means 5 hybrid orbitals are there. That is sp3d hybrid orbitals. In SF4, sulfur hybridization is sulfur valence electrons are 6. 4 fluorines are there. Each fluorine valence electrons are 7. This is 28 plus 6 is equals to 34. Divided by 8. It goes 4 times. So that 8 4s are 32 plus this is the quotient 1. Remainder is 2. So when remainder is there, 2 by 2 is equals to 1. So that this is the quotient 2. Quotient 1 plus quotient 2. 4 plus 1 is equals to 5. So that hybridization is sp3d hybridization. In iodine fluoride molecule, iodine 7 valence electrons, fluorine also 7 valence electrons. Total number of valence electrons are 14. So to be divided by 8, so that we get the 8 ones 8. So that remainder is 6. This is the quotient 1. This is the remainder 1. So the remainder has to be divided by the 2. So that we get the 3. So this is the quotient 2. Now quotient 1 plus quotient 2. That means 1 plus 3 is equals to 4. Hybridization is sp3 hybridization. In case of IF3 molecule, iodine 7 valence electrons, 3 fluorines are there, 3 into 7. So total is equals to 28 valence electrons. Divided by 8. 8 threes 24. So that this is the quotient 1. Remainder is 4. So the remainder has to be divided by the 2 to get the next quotient. That is quotient number 2. Quotient 1 plus quotient 2. That means 3 plus 2 is equals to 5. Hence hybridization is sp3d hybridization. Here, see, iodine and fluorine both belongs to the 17th group elements only. That's why directly I am taking here 6 atoms with 7 valence electrons. Totally 42 valence electrons are present. To be divided by the 8. 8 5s are 40 plus remainder 2 is present. This is quotient 1. So remainder 2 by 2 is equals to 1. We are getting the quotient number 2. So that quotient 1 plus quotient 2. That means 5 plus 1 is equals to 6. Hybridization is sp3d2 hybridization. Let us see the IF7 molecule. Here 7 plus 1, 8 17th group elements are there. So 8 into each atom valence electrons are 7. So the total number of valence electrons are equals to 56. So that it has to be divided by the 8. It goes 7 times. This direct quotient comes and no remainder is present. That's why hybridization of this molecule is equals to sp3d3. 3 plus 3, 6 plus 1, 7 hybrid orbitals are present in the IF7 molecule. Now let us see the Cl2O7 molecule here. Chlorine hybridization. Chlorine belongs to the 17th group, oxygen belongs to the 16th group. So 2 chlorine atoms are there, each chlorine 7 valence electrons plus 7 oxygen atoms are there, each oxygen 6 valence electrons are present. Here this is 14. This is 42. Total value is equals to 56 divided by 8. Again we are getting this 7. So that hybridization is equals to sp3d3. So like this we can calculate some of the examples. We shall see even more advanced examples. In this example, chlorine 7 valence electrons, 2 oxygens 2 into 6 plus negative charge is there, it has to be added. So this total number of valence electrons are equals to 20 divided by 8. 8 to the 16. This is the quotient 1 plus remainder 4 is there. So this remainder 4 has to be divided with the 2 so that we get the another quotient 2. So quotient 1 plus quotient 2, that means 2 plus 2 is equals to 4. Hybridization of chlorine is equals to sp3. And in this case, again chlorine 7 valence electrons, 3 oxygens, 3 into 6 plus 1 negative charge is present. Total number of valence electrons are 26 by 8. This value is equals to 8 3s are 24. This is the quotient 1 plus remainder 2 is there. So that 2 by 2 is equals to 1. This is the quotient number 2. So quotient 1 plus quotient 2, that means 3 plus 1 is equals to 4. Hybridization is sp3. ClO4 minus, chlorine 7 valence electrons and 4 oxygens are there. 4 into 6 plus extra 1 electron. Total number of valence electrons are 32 divided by 8. So 8 4s are 32. Total number of valence electrons giving the 4 hybrid orbitals. That's why here hybridization is equals to sp3 hybridization. Next, PCl4 plus molecule. Phosphorus 5 valence electrons. 4 chlorines are there. 4 into 7 valence electrons minus 1. Total number of valence electrons are 32 by 8 is equals to 4. Hybridization is equals to sp3. PCl6 minus, phosphorus 5 valence electrons, 6 chlorines are there. Each chlorine has 7 valence electrons and 1 negative charge is there. It has to be added. Total number of valence electrons are 48 valence electrons are there. It has to be divided by the 8, giving the 6. So hybridization is equals to sp3d2 hybridization. Then in SOF2 molecule, so here sulfur 6 valence electrons are present, oxygen also 6 valence electrons are present, fluorines 2 are present, each one is having the 7 valence electrons. So total number of valence electrons are 26 valence electrons to be divided by the 8. So 8 3s are 24. This is the quotient 1 and remainder is 2. So the remainder has to be divided by the 2, which is giving the again 1. This is the quotient number 2. Quotient number 1 3 plus quotient number 2 1 is equals to 4. Hybridization is sp3 hybridization. So let us see these molecules which frequently been asked in the examinations. Nitrogen 5 valence electrons are there plus 2 oxygens, 2 into 6 valence electrons. Positive charge has to be subtracted from the total number of valence electrons. So the total number of valence electrons are 12 plus 5 is equal to 17 minus 1 is equals to 16. It has to be divided by the 8 so that direct quotient is 2. So hybridization is sp hybridization in NO2 plus for the nitrogen. In NO2 minus, nitrogen hybridization is nitrogen again 5 valence electrons, 2 oxygens are there, 2 into 6 valence electrons, negative charge, that's why we have to add the plus 1. So total number of valence electrons, see this is 12, 12 plus 5 equals to 17, 17 plus 1 is equals to 18. So 18 by 8 is equals to here 8 2s are 16. This is the quotient 1 plus remainder 2 is there. Remainder 2 by 2 is equals to 1, that is quotient number 2. So that quotient 1 plus quotient 2. So this value 2 plus 1 is equals to 3. Hybridization is sp2 hybridization. In case of NO2 molecule, nitrogen 5 valence electrons are there, 2 oxygens are there, 2 into 6. So the value is equals to 12 plus 5 is equals to 17 valence electrons are there. It has to be divided by the 8. So that 8 2s are 16 plus 1 is there. This is the quotient 1. This is the remainder. Already we discussed in the rules. If the remainder is less than 2, it should not be divided. It has to be added directly. So that 2 plus 1 is equals to 3. So hybridization is equals to sp2 hybridization. In N3 minus ion, 3 nitrogens are there, 3 into 5 valence electrons plus 1 extra electron is present. So this is 15 plus 1 is equals to 16, has to be divided by the 8. So the quotient in this case is equals to 2. So hybridization of this central atom, central nitrogen atom in this case, azide ion is equals to sp. In case of I3 minus, 3 iodines are there, each iodine valence electrons are 7 plus 1 electron is present extra. So this is 21 plus 1 is equals to 22 valence electrons, divide with the 8. 8 2s are 16, so that here quotient 1 plus remainder is equals to 6 is the remainder. Then this remainder has to be divided with the 2, so that we are getting the 3. This is the quotient number 2. So add the quotient 1 plus quotient 2. That means 2 plus 3 is equals to 5. Hybridization is sp3d hybridization. In case of I3 plus, the central iodine hybridization is 3 iodines are there, 3 into 7, positive charge, so that you subtract the positive charge value from the total number of valence electrons. So that here 21 minus 1 is equals to total number of valence electrons are 20 by 8. So 8 2s are 16. This is the quotient 1. Plus 4 is the remainder. So the remainder 4 value has to be divided with the 2, so that you are getting the next quotient 2. So that quotient 1 plus quotient 2 is equals to 4. So hybridization of iodine in I3 plus equals to sp3. So we shall see some more examples now. So in this case, xenon 8 valence electrons, 2 fluorines are there, 2 into 7 valence electrons. So total number of valence electrons are 22. Divide with 8. So it gives 8 2s are 16. So this is the quotient 1. And the remainder is 4 plus 2, 6 is the remainder. So that remainder has to be divided with the 2. We get the 3, that is the quotient number 2. 2 plus 3 value is equals to 5. So hybridization for this one is sp3d. And NO3 minus ion, nitrate ion. So let us see here, 5 valence electrons are present for nitrogen, plus 3 into 6 valence electrons for every oxygen, plus extra 1 electron. So the total number of valence electrons are 18 plus 6 is equals to 24, divided by the 8. So 8 3s are 24, so that hybridization is equals to sp2. In case of XeF2, xenon 8 valence electrons, oxygen 6 valence electrons, 2 fluorines are there, each fluorine 7 valence electrons are there. So let us try to find the total number of valence electrons. This is 14, 14 plus 6, 20, 20 plus 8 is equals to 28 valence electrons are present, to be divided by the 8. So that 8 3s are, this is the quotient 1. So 8 3s are 24, plus 4 is the remainder R1. The remainder has to be divided by the 2 to get the next quotient, that is quotient number 2, Q1 plus Q2. That means 3 plus 2 is equals to 5. So that hybridization is equals to sp3d. BrO3 minus, bromine valence electrons are 7 and oxygen valence electrons are 6. So 3 into 6 plus extra 1 electron is present. So total number of valence electrons in this case, so 6 into 3, 18. 18 plus 7 is equals to 25, plus 1 is equals to 26. To be divided by the 8. So 8 3s are 24, quotient 1, and remainder is 2. So that here 2 by 2 is equals to 1, that is the quotient number 2. So quotient number 1 plus 2, that means 3 plus 1 is equals to 4. Hybridization is sp3. XeF3 plus, xenon 8 valence electrons, plus 3 fluorines are there, 3 into 7 and minus 1 because positive charge is present. So that total number of valence electrons 21 plus 8 is equals to 29. 29 minus 1 is equals to again 28. So 28 by 8 means here we will get the 3, that is the quotient number 1, plus 4 remainder. So that 4 by 2 is equals to 2 is the quotient number 2. So 3 plus 2 gives 5. That means hybridization is sp3d. In case of carbon dioxide, carbon valence electrons are 4. 2 oxygens are there, 2 into 6. So total number of valence electrons here 12 plus 4 is equals to 16 divided by 8. So that we will get the 2. Hybridization of the carbon is equals to sp hybridization. So let us see these examples also. Xenon 8 valence electrons, 4 oxygens with 6 valence electrons. So total number of valence electrons are 6 4s are 24. Total number of valence electrons are 32 to be divided by the 8. 4 hybridization is equals to sp3. And XeO3 8 xenon valence electrons, 3 into 6 valence electrons of every oxygen. So that this is equals to 18. 18 plus 8 is equals to 26 divided by the 8. So 8 3s are 24. This is the quotient 1 plus a balance, that is remainder value is equals to 2 is there, that is remainder 1. So remainder value has to be divided by the 2 to get the quotient number 2. So quotient 1 plus quotient 2, that means 3 plus 1 is equals to 4. So hybridization is sp3. Now let us see this example also. ClF7. Here chlorine, fluorine both belongs to the same group, that is 17th group elements. So let us take together. So 8 17th group elements are there. So each valence electron is equals to 7. So total number of valence electrons are 56 to be divided by the 8. So that quotient directly is equals to 7. That means hybridization of the chlorine is sp3d3. So 3 plus 3 6 plus 1 7 hybrid orbitals are there. In ICl2 plus 7 valence electrons of iodine plus again 2 into 7 valence electrons of the chlorine and 1 positive charge, so it has to be subtracted. So total number of valence electrons 21 minus 1 is equals to 20 divided by the 8. So 8 2s are 16, that is quotient number 1. Remainder is 4. So 4 balance, that is the remainder. So this remainder has to be divided with the 2 to get the next quotient number 2. So quotient 1 plus quotient 2, that means 2 plus 2 is equals to 4. Hybridization is equals to sp3. In case of SF6 molecule, sulfur valence electrons are 6 and fluorine valence electrons are 7. So total number of valence electrons are 48 to be divided by the 8. So we will get this 6. Hybridization is equals to sp3d2. In case of XeF4, xenon valence electrons are 8, 4 fluorines, each fluorine valence electrons are 7. Total number of valence electrons are 36 to be divided by the 8. So here total number of valence electrons here is 8 4s are 32. This is the quotient 1 and remainder is 4. So this remainder has to be divided with the 2 to get the next quotient number 2. So quotient 1 plus quotient 2. 4 plus 2 is equals to 6. Hybridization is sp3d2 hybridization. XeF6 molecule 8 plus 6 into 7 is equals to total number of valence electrons 50 by 8. It goes 6 times. This is the quotient 1 plus 2 is the remainder. So 2 by 2 is equals to 1, that is the quotient number 2. So we are going to get the quotient 1 plus quotient 2. That means 6 plus 1 is equals to 7. So that hybridization is equals to sp3d3. 3 plus 3, 6 plus 1, 7 valence electrons are there. So dear students, I hope you understand all these classes. So let us try to repeat 2 examples where remainder is 1. Those examples are important for us. So we shall see those examples once again. Let's repeat these examples. Nitrogen 5 valence electrons and 2 oxygens. Together 12 plus 5 is equals to 17 valence electrons to be divided by the 8. So 8 2s are 16. This is the quotient 1, remainder is 1. So when remainder is 1, not necessary to divide with any number. So the direct value is equals to 3. Hybridization is equals to sp2. In the similar way, here also IF7, there are 8 17th group elements are there. So that 8 into 7, each atom is having the 7 valence electrons. Total number of valence electrons are 56 by 8 is equals to 7. So that hybridization is equals to sp3d3. Dear students, I hope you understand today's class. There may be many videos available to explain the hybridization tricks, but here it is the closest approach to get the most accurate answers for the most of the examples that is being asked in the entrance examinations. If you really understand my class, please do like and share it with your friends. Thank you one and all, and we shall meet in the next class.